of friends. So in this video, I will tell you how you can work with open source data lakehouse tools. No need to spend much on cloud data lake tools. So I will configure the setup with the data lake Trino, Hive, and MinIO. MinIO will be used to store my data files that will be in package files. Then you can query those data by using Trino. So let us have the setup, and also we'll see that how you can create the program so that it can be fetch data from Trino, from MinIO, okay, and you can work with the data lake tables. So before I take you to the tutorial, let me show you how the architecture will look like. Uh, so here, if you see the architecture of Data Lakehouse, that is in completely open source. Data will come from different sources like your APIs, images and videos, or it can be flat files like Excel, CSV, or JSON. Then also data can come from the RDBMS like your database storage, right? So once you connect those data with the ETL pipelines. For the ETL pipeline, you may use plain Python and Apache Lighthead is also open source tool, or you can use Apache Spark as well if you want to transform your data with distributed, in distributed mode. Then you can do that. So this ETL layer will bring the data to the MinIO layer, to the storage layer, right? So directly you can convert the data into a data lake table and put in your MinIO storage, and you can take help of Trino as well. So if you want to work with a SQL layer, then you trigger those SQL queries, then Trino SQL queries that will take your data to insert data into a MinIO storage or query your data from the MinIO storage, or these things you can do, right? So in MinIO, what the best practice will be, we have to keep our data in three different layers like bronze, silver, gold. Bronze stands for this is standard practice in enterprise. When you take your data, okay, when fetch your data from the source, you put it in the bronze layer. So it is the as it is data layer. So then if you do any transformation like you perform deduplications, you perform schema standardizations, you perform joins by joining different tables, then you clean, you enrich the data. So all these data points then again store in the silver layer, in the silver bucket. Then once your silver data is prepared, then you have PI, you create a semantic layer, like you aggregate the data and you keep the data in different dimensions, then you put it in the gold layer. Okay, so this is how you prepare and store your data in the data storage system, right? Once you store the data, then again Trino will be used to query the data from silver and gold layer and give it to the BI layer, the BI dashboard layer, right? So internally, Trino will use Hive Metastore to keep all their metadata. Like if you do any, tables, like column transformations, or to keep the schema, table columns, all this. So Trino will use Hive because, as you know, MinIO data will be stored in files, in flat files. To query them, so there are additional metadata required for the Trino. So Trino will be used Hive to keep those data in the metastore, right? Again, Hive will also internally use MySQL or PostgreSQL to keep the data. So BI dashboard will again consume BI dashboard like your Tableau or your Power BI. If you are opting open source, then Apache Superstore or Grafana. So those tools can be used to fetch the data from a storage system through Trino. Okay, so this will bring the data into the BI dashboard, and you prepare beautiful dashboards, and that will be consumed by your dashboard user. This is how a open source data or a data lakehouse architecture will be. Without further delay, let us see a demo how we can configure and work with the open source data, work with these open source data lakehouse tools.
Let us see the demo. Before I show the demo, like how you can do a transactions with your data lake. So let me show you how I have configured the Trino. I have done it through Docker. So this is my Docker compose file. So here I have created four services. So one is the Trino coordinator. So I have to use this Trino latest image, and I'm running this in 8080 port. This is the default port of Trino. Then, like I have also used MariaDB for the Hive Metastore. This is the MariaDB services, and here I have configured Hive as well. Then I have configured MinIO. So MinIO is the storage layer. So all I configured in single node, but you can configure it in multiple node as well. The MinIO, the Trino that you can run in multiple node also. So this is my configuration. So once I configure this, I run it in a Docker compose command. Services, Delta Lake services like Hive Metastore, MinIO, Trino, and MariaDB is running successfully. So let me show you. Let me open the MinIO instance. This is my MinIO instance. So now I'll create a pocket in MinIO. So I'll keep the pocket name as Data Lake hyphen APC. So my bucket is created. So I am inside this bucket. So here I will create a folder called uh, bronze, because I want my data should remain in bronze, silver, and gold layers, right? So I create a directory inside that bucket named as bronze. Now let us push some files into this bronze directory. So this is my Python code. So I have a file called sample superstore.csv. I have downloaded it from Kaggle. So I want this table to convert this particular CSV to convert into a Delta Lake table and push into my bronze layer, right? My bronze directory in MinIO. Okay. So how I'll do that? This is my command. I load the data in a data frame, then I convert it into a PyArrow table. Remember, this PyArrow table is a compatible format for Delta Lake, so I converted that. Then I use the storage options of MinIO. So all this credential I have given. Then I have given the table path like data like ABC bronze. I wanted the name of my file or Delta table will be Superstore. So I kept that. This is the code I have used to create the write into my MinIO Delta Lake table. So I've used the mode as overwrite. So if there is any existing file, it will overwrite. So let us execute this script. Yeah, so now you can see data successfully written in Delta Lake table. Let us see in my MinIO instance whether the files are created or not. Yes, so successfully a table called Superstore is created. This is a Delta Lake table. As I explained in my last video, this Delta Lake table contains a log file and as well as a PyQ file. So this is the data layer and this is the metadata of this data. Okay. Uh, Now let us see how we can access this table in Trino. So I have configured Trino, and for the Trino client, I am using this client ID called dbvr, right? dbvr is a tool where you can use it as a client for many databases, right? So Trino is one of them. Now Trino, like before I connect to the Trino, let me tell you the Trino configuration. So I showed in my Trino configuration that this is my service information I have kept in my Docker compose file, right? And inside set etc, I have kept all my Trino configurations. So the important configuration here is you need to create a catalog. So I have created a catalog called ABC. So if you see, this is my Trino catalog. So once I create this catalog and I restart my Trino service, then my catalog is available in Trino that I can see in my dbvr, right? So this is my ABC catalog where I have two schema default and information schema. Those are default schema. Now I will create another schema as bronze. Then subsequently I will create silver and gold as well to keep my silver and gold standard data. So let us create the schema. The command to create a schema is this create schema if not exist abc dot bronze. So I need to create a bronze schema because I have because as I told I will keep my data in bronze, silver and gold, and I have kept the location name. So this location is already is with MinIO, so I have created that. So let me execute this script. Now you can see my schema is successfully created. Let me refresh this catalog. Yes, my bronze table is available, and you can see the table is not appeared here. Since I have my Data Lake table is already in this bronze subdirectory. In this bronze directory, I have the Delta Lake table called Superstore, but this is not appearing in Trino. So to do that, I need to register this table in my Trino instance. So to register the table, my Trino query would be this. So this is a query. So I am using the catalog called ABC and my schema name is bronze that I have created, and my table name is Superstore and my table location path is this. So let me run this. Yes, now my table is registered. So if I refresh the schema, now you can see my table. Okay, now I can write a Trino query to see the data, to fetch the data and to any CRUD operation into this table. Okay, let us execute a select statement. So this is my Trino query. So let me execute this. Yes, successfully I'm fetching data from my MinIO instance, right? So let me transform this data and put it in silver layer by using some Python script. Let me do that. So this is my script I've used to fetch the data in Python and put it in a data frame so that I can see. Uh, this is my connection string to establish the connection with Trino. Then this is my query select star from bronze.superstore. Superstore is my table name and bronze is my schema. I execute this query. Now let me run this. Yeah, so I can see 9,994 record, which this super the superstore data hold. So this is my data. Now let me do one thing. Let me filter this particular data sets by state is equal to Florida, and my aim is to keep this data set, this filter data set in the silver layer. Okay, so this is the Trino query I have used because I wanted to do this with Trino, not directly with Delta Lake table of MinIO. So I'll do it through Trino. So here I have established a connection. Then in my query, Trino query will be create table silver.florida superstore. So if I'm doing in this way, then no need to register a table because automatically the table will be created and the data will be created in my storage layer like MinIO. So let me execute this. Yeah, it shows some error. I think I've done some mistake. Sorry, it's showing the schema is not found. So let me create a schema in Trino first, then I can use this command because this is using the silver schema there. So the same thing, the same way I will create the schema. So instead of bronze, I would like silver, red silver, and here I'll use the folder name as silver, right? Because in storage, I need to store my data in a silver directory as well. My schema will be silver in Trino, and also my directory in MinIO will be named as silver, right? So let me execute this. Yeah, you can see. So let me refresh. I've created a schema called silver. Now let us see the MinIO instance as well. So here you can see there is a directory called silver created, right? So now there is no table in my silver. So let me run the script again. So which will create a table, a delta lake table basically in my silver directory, right? Yes. So Florida data successfully written. So let me refresh my MinIO instance. Yeah. So you can see this is my delta lake table, which contain the metadata as well as the data. So now, let us fetch the data from this silver layer or from this, new table, new delta lake table I have created, and let us see how many data are loaded in this particular table. So if I run this script, so my silver table is containing 383 records, which is of Florida state only. So now since we have created a silver table called Florida Superstore in my MinIO storage, now let us connect a BI tool like Tableau or Power BI or Superset in order to create a visualization of those data. So I will be using Tableau. So but you can connect Superstore, so Superset and Power BI or Grafana as well. So let me establish a connection from Tableau. So here I'll be using the JDBC connections. In the URL, I have mentioned Trino and my Trino server, and my catalog I'm using ABC. So credential I need to provide. Then once I do a sign in, yeah, so you can see my database. My database will be catalog is ABC and schema. So I want a visualization from the silver schema, right? So here is the table you can see Florida super stage. So let me connect, drag and drop in my data source. Then yeah, so you can see my data. So if you want to see the data as well, yeah, this is the data. So know how it is now. So quickly, if you can want to create a visualizations, so you can do that. So let me state and the state of cells. You can see, those total cells of Florida. So if I show you count, the total 383 records in my Florida, in my the silver table. So now what we'll do, like we'll do another insert in this table by taking a data of California state, and let us see a new version of this file is created in this MinIO. So this is my delta lake table in my silver layer. So here I am writing the code which will basically take the data of California state from the bronze superstar table, and put it in my silver Florida superstar table, right? And let me run this. Yeah, now you can see this query has inserted 2001 records into my existing Florida Superstar Civil table, right? So before it contains 383 records. Now after I execute this insert command, it is containing 2384 record. So if I will see the storage layer, let me refresh this. Yeah, so now it is containing two version of my data. So earlier it was 25 KB, now it is 88 KB, right? So which is great. So automatically the data is version controlled. So any point of time I can see what was my data in my version 0. So this is what we call time travel. Now let me show you like what is the version in my version 0 table. If I run this script called select ABC Silver Florida Superstar for version of 0. Now it will show me like in version 0 it was 383 record. In version 1 it is 2384 record. So now since I have done a insert by taking the California state data and I pushed in my MinIO layer, then let me refresh this dataset and see state of California is added, and yes, the state of California data is also added. So you can set automatically refresh in order to refresh this data set. So when your data will be added in your instance, automatically your BI layer will consume that automatically. So this was a demo. I think you have enjoyed it, and if you have any query, then please write me in comments. So I would like to reply on that. Thank you so much.